Hello everyone and welcome to yet another video where we're gonna review a solution to an in-class problem. We are going to now talk about the problem in which we are asked to estimate the probability that my next phone call will be a scam. And of course, this is a problem that is only solvable within the next setup. So we are given three pieces of information. The first one is that 80% of the calls that I received are robocalls. Then we are told that 80% of those robocalls result in a scam. And finally, we are told that 10% of the rest of the calls are also a scam. Now, the key here is to realize that by saying the rest of the calls, we are also saying that we are referring to the calls that are non-robocalls. Okay, so our first job here is going to be trying to determine the correct notation here. So here we have two possible events. A is going to denote the event the call is a robocall, such that not A would mean that the call is not a robocall. Similarly, we have a second set of events, B, which corresponds to the cases in which the call is a scam, and therefore we have its complement, not B, that corresponds to the cases in which the call is not a scam. Now, the key here is to distinguish what are the pieces of information we are given. So we are told that 80% of calls are robocalls. What does this correspond to? Well, this is telling me that the probability of event A, which we had just denoted as the call being a robocall, is 0.8, which is equivalent notation as saying 80%. Then we are told that 80% of those robocalls are scams. That is equivalent to a conditional probability. Now we are given the probability that the call is a scam, given that it has already turned to be a robocall. So 80% of those robocalls that I have received turn into scams. So from the universe of cases in which a robocall has already happened, what is the probability that now it's also going to be a scam? That is 0.8. And finally, this last statement here tells us that the probability of the call being a scam, given that it was not a robocall, is still 0.0, is still of 0.1 or 10%. These are equivalent ways of saying this. So these are the three pieces of information we are given. This is the very first part of our problem, trying to locate what the information is. Now, let's try to work on building up some intuition here. Notice here that we are given as part of this problem the probability that a call would be a scam when it is a robocall, but also the probability that the call is a scam when it is not a robocall. And there are only two possible scenarios, right? When I pick up the phone, it is either a robocall or it's not a robocall. There are not other scenarios. So now what we're going to have to do is we're going to have to weight these two conditional probabilities by what we know about the baseline probability that any call that I answer on the phone is indeed a robocall. So now, when we want to compute the probability of a call being a scam, that is just P of B, what I'm going to be doing, because these two are mutually exclusive events, right? Either the call is a robocall or the call is not a robocall. So now, what I'm going to be doing is I'm going to be summing the probability of all these happening together. Let's subtract this plus here for an AND notation so that it's not confusing, plus the probability that it's not a robocall, but it's still a scam. So we're going to have to sum these two together. Why? Again, because these two scenarios are mutually exclusive. So we know by the sum rule that we can just sum these two probabilities. Now, how do we compute these joint probabilities? Well, we're going to do that by using OR product rule. P of B is going to be equivalent to P of A and B plus P of not A and B. I'm going to substitute these two now. So I know that this is a joint probability. From what I know about the product rule, I know that I can safely substitute this into the pieces of information that I already have. I can substitute this joint probability into this probability, and I have both pieces of information here because of the problem setup. And then I'm going to add the joint probability of the call not being a robocall and it still being a scam as, again, the product of the marginal probability of the call not being a robocall times the probability of the call being a scam when it is not a robocall. And again, this piece of information we have here, and this piece of information we were not given explicitly. We are not given explicitly the probability that the call is not a robocall, But we know from the complementary rule that P of not A has to necessarily be equivalent to 1 minus P of A. This is our complement rule. So I can substitute this value here easily as 1 minus 0.8, 0.2, and this one is much more direct, so P of A I already have. Then we can substitute these two conditional probabilities that I am given as part of the setup. So here I have P of B given A and P of B given not A, right? And then I know that I have to multiply them because that's how we compute joint probabilities. And if we are going to do the calculations, you can just grab a calculator. We get these beautiful numbers here, and now we just have to sum them together. So 0.64 plus 0.02 results all together in 0.66, and we have reached our final answer. This is the correct answer for this exercise. Hope that was clear.